My name is Muskan, and with my teammates Malini and Aditi, we are going to present a presentation on topic multi-threading. Next slide, Malini. So, our team member, of course, Malini, Aditi, and me. Here is the contents what we are discussing about today. That is introduction, what is thread, advantage, disadvantage, life cycle, method of thread class, thread priority, synchronization, and deadlock. So coming to the introduction part, so what is multi-threading? Before going to multi-threading, let's talk about what is multitasking. So multitasking is a process of executing multiple tasks simultaneously. We use multitasking to utilize the CPU. So multitasking can be achieved by two ways, that which means that it can be classified into two types, that is process based multiprocessing and thread based multi-threading. So what is multiprocessing? That is process based multitasking, executing multiple tasks simultaneously where each task is a separate independent process or program is called process based multitasking, that is multiprocessing. Taking the example of typing a Java program in Notepad or listening a audio song. These are the example of multiprocessing. Coming to thread-based multitasking, that is multi-threading. Executing multiple tasks simultaneously where each task is a separate independent part of the same program or process is called thread-based multitasking. So, Malini, leave the same slide only, don't move it. Another. So here in the slide, we can see it is written that multi-threading is a Java process of executing multiple threads simultaneously. What I have said just now. However, we use multi-threading then multi-processing because thread uses shared memory area. They don't allocate separate memory. CPU takes memory and context switching between the threads take less time than process. We use multi-threading is mostly in games and animation, etc. Malini, next slide. So, what is thread and how it can be created? So, thread is a lightweight subprocess, a smallest unit of processing. It has a separate path of execution. Threads are independent. If there occurs exception in one operation, it will make the other fail. Thread shares a common memory area. Malini, move to next slide. In the diagram, we can see that inside a operating system, there are multiple processes in which inside a process threads are working. So in this diagram, we can imagine that how a thread occurs or how a threads works. Okay, back to the slide, Malini. So we can create thread by two ways, by extending a thread class or by implementing learnable interface. So by extending thread class in this thread we can able to create a thread and able to start a thread by calling a start method of thread class. By implementing runnable interface in this, we can able to create and execute thread. The runnable interface should be implemented by any class. Runnable interface have only one thread method named run, where run method is abstract method basically. Next slide, Malini. Coming to advantage and disadvantages of multi-threading. So first is advantages. It improves performance. So multi-threading will help increase the overall performance of an application, especially on systems with multiple processors or cores. It allows multiple tasks to run currently, utilizing the available CPU resources more efficiently. Second point, responsiveness. In single-threaded environment, if a long-running task blocks the main thread, the entire applications become unresponsive. Multi-threading can prevent this issue by running such tasks in separate thread, ensuring the application remains responsive. Third point is better resource utilization. Multi-threading allows better utilization of system resource by keeping the CPU busy while waiting for input-output operation or other tasks to complete. Fourth point is simplified modeling. Some problem can be more naturally modeled using multiple threads. This makes the program easier to design, understand, and maintain. Fifth point is parallelism. Multi-threading enable parallelism, which can lead to significant performance improvement in application that can be divided into smaller and independent tasks. Coming to disadvantage, so first point is complexity. 1 minute. So coming to complexity, multi-threading add complexity to the program, making it more difficult to design, implement, and debug. Developer need to be aware of the synchronization, deadlock, race condition, and other related issues. Second point is synchronization overhead. To avoid data corruption and maintain consistency, developer must synchronize access to shared resource, which can result in additional overhead and reduced performance. Third point is context switching. Context switching between threads consumes CPU time and resources, which can lead to performance degradation if not managed efficiently. Hard to predict behavior. That is the fourth point. Due to concurrent nature of multi-threading, the behavior of the program can be hard to predict and reproduce, especially when it comes to debugging. Last but not the least, coming to the last disadvantages, so the perform limited by hardware. The performance benefits of multi-threading are limited by the number of available cores or processor in the system. In some cases, excessive use of thread can lead to performance degradation instead of improvement. So I will request Aditi to continue further.
Thank you, Muskan. Good evening, sir. My name is Aditi Deep, and in this slide, I'm going to talk about what is a life cycle of a thread. So, before we directly dive into this topic, what is a life cycle? Let us understand the meaning of life cycle of a thread. So, if I split this word thread cycle, then the meaning of is basically thread is the smallest part of a process which allows a program to operate more efficiently by running multiple tasks simultaneously. And if I talk about the meaning of cycle, then a cycle means a series of events that are regularly repeated in the same order. So if we formulate this word together, then we come across the meaning that basically thread cycle is a smallest part of a process which allows a program to operate more efficiently by running multiple tasks simultaneously in a series of events that are regularly repeated in the same order. So basically, thread cycle is divided into five subparts, which is the first one is new, the second one is active, third one is block or waiting state, fourth one is time waiting state, and the last but not the least is terminated state. Muskan, kindly switch to the next slide. Yeah. So, in the first state, that is a new state. So, when we create any new thread, then it is in the new state. The thread which hasn't initiated its execution basically reside in this state. So, if I take the example of a seed, so basically, seed contains all the properties of its upcoming sapling or a tree or a plant. So it contains it is basically in inactive state. If we sow seed, then it may chance that whether it will germinate or not. If it will germinate, then it basically goes into the active state. Now coming to the next step, which is active state. So active says that whenever the start method is called or invoked, then it moves from the new state to the active state. In this state, there are two mainly stages. First one is runnable state, and the second one is running state. By runnable state, I mean the thread basically currently in executing or ready to execute as soon as the system or thread scheduler assign its CPU input. Or if I talk about the running state, then in this state the thread is already executing its line of codes. Now coming to the third state, which is blocked or waiting state. So if I come across the meaning of blocked or waiting state, then in this state basically the process mainly pause or block for some chunk of time. So basically, when a thread remains inactive for a span of time or a certain amount of time, but not in permanently inactive state, then the thread is either blocked or in a waiting state. Now, moving to the fourth point, which says time waiting state. So when we use sleep method, then it put the thread in the time waiting state. It basically allots a certain slice of time. So when the time runs out, the thread gets invoked and again start its execution from where it stopped its execution. Now moving to the fourth state, which is terminated state. It's also called dead state. In this state, when the thread exits from the cycle or the thread is no more in the system, then the thread is considered to be dead state or a terminated state. When the thread is terminated, it will never be activated again. So, as I told you earlier about the different stages of the life cycle of a thread, as you can see here, the diagrammatical view of thread life cycle. So in the first state, which is in a new state, the thread is created. After that, it goes to its next state, which is active state. In I told you earlier that there is two stages, mainly runnable state and running state. If this thread is active to run, then it will reside in a runnable state. And if the thread is already executing its line of code, then it will reside in a running state. So if a it method is called, then thread which is already executing its line of code in a running state, it will switch back to its runnable state. Otherwise, it will further goes to a end of this cycle in a dead state or terminated state. Again, if I say the thread is executing its line of code in running state, and some sort of methods like wait, sleep, or suspend method is called, then it will then the thread will move to the blocked state, or we can say waiting state or sleeping state. Um, After that, when we notify or when we call uh, wait method or notify method, then it will invoke wait method. Or if we call resume method, then it will wake the thread from the suspend method. Or when the time is up, or the if the certain slice of time um, in which this thread goes into the pause state or hybridized state, where it remains in an inactive state, then it will definitely move to the um, runnable state. Um Next slide. So this slide will be covered by Malini.
Thank, thank you, Aditi. Good evening, everyone. So, my mates have already explained you about the thread, and we are here to give a light on the priorities that is given to a particular thread. So, each thread has a priority, and it is represented by the number between 1 to 10. Most of the cases, the priority is scheduled by the thread scheduler, known as preemptive scheduling. but it's not guaranteed as it depends on the JV. So here we talk about the next point, talk about the method of thread priority. We basically have two methods from which we can give priority to our thread, that is get priority and set priority. First, let's talk about get priority. So this method basically returns the priority of the given thread, and the set priority is a method that updates or reassign the priority of the thread to a new priority. The method throws illegal argument exception if the value of the new priority goes out of the range, which is 1 to 10. Here, the next slide talk about the constant priority defined in the thread class. So we have three constant priorities in the thread class. The first one is the min priority, which has the value of 1, and the next one is the norm priority, which has the value of 5. Uh, the last priority, which is the max priority, and which has the value of 10. Moving ahead to the methods of the class, here we can see that we have several methods and descriptions. Let's talk about them one by one. So the first one is set name method, uh, which is used to give the name to a particular thread. Then we have get name method, which returns the thread name. And we have get priority method, which returns the thread priority. Is alive method, this basically checks whether the thread is still running or not. Then we have join method, which wait for a method to end. Then we have run method, which is the entry point of the thread. Sleep method, that suspend the thread from a specified time. Then we have the start method. Start method is basically being start by calling the run method only. Then we have the current thread method, which returns a reference to the currently executing thread object. Last but not the least, we have get ID, which returns the identifier of this thread. Next slide talks about the synchronization in Java. So, synchronization in Java is a process which basically allows only one thread at a particular time to complete the task entirely. By default, JVM controls all the thread present in the system to access the shared resource. Synchronization can be done by using the synchronized keyword. This can be used on the top of the method or a block. So we have the next point, that why do we need the synchronization in Java? Here we have the two exclusive point, which is to prevent the thread interfaces or interleaving, and the second point is to provide consistency to the program. Here, the next slide talks about the types of synchronization. So we have two types of synchronization in Java, which is the process synchronization and the thread synchronization. Let's talk about process synchronization. When multiple threads are executed simultaneously, process synchronization ensure that each thread reach at a particular state and agree to a certain set of actions. The next one is the thread synchronization. When multiple threads want to access the same resources, the thread synchronization make it sure that only one thread get the access at a particular time to the resources. Here, the next slide talks about the inter-thread communication. Basically, in Java, this method allows several threads to communicate with each other. It also provides an effective way for multiple threads to communicate with each other by minimizing the CPU idle time. Then we have the next point on it. CPU ideal time is a procedure that prevents the CPU cycles from being wasted. When many threads are running at the same time, they may need to communicate with each other by sharing some information. A thread exchanges data before or after changing its state. Communication between thread is vital in a variety of cases. Thank you, everyone. The next slide will be explained by Muskan. Ahead to you, Muskan.
Sorry, Malini. This slide will be explained by me. Um, so in this slide, I'm going to talk about what is lock in Java. So as we know, a lock is a thread synchronization mechanism similar to synchronized blocks, which means a lock is a flexible and complicated thread synchronization mechanism than the standard synchronized block. So locks are formed using synchronized block. So you can't omit this synchronized keyword. So the lock may be tool for controlling access to a shared resource by multiple threads. Basically, a lock provides exclusive access to a shared resource, which means just one thread at a time can acquire a lock. That is, if a thread wants to access the resource, then the lock would be acquired first. The basic difference between synchronized keyword and the lock is that with locks, you can release and acquire the lock in any order. Whereas, if I talk about the synchronized keyword, then by using synchronized keyword, you can release the lock only in the order it was acquired. Similarly, synchronized block is used to prevent multiple thread from executing a portion of a code in a method at the same point in time. Whereas read write lock, uh, basically a feature in lock, allow in multiple readers at the same time, but only if no writers are already in. um, Basically, some locks may allow concurrent access to a shared resources, like read lock of a read write lock. So in the next point, we will see synchronization. Sorry. Yeah. Synchronization is built around an internal entity known as the lock or monitor. Every object has a lock associated with it, as I already told you about this. So um, so Malini, move to the next slide. So this slide will be explained by Muskan.
Thank you, Aditi. So, coming to the last but not the least top point, what is deadlock in multi-threading? So, synchronized keyword is used to make the class or a method safe, which means only one thread can have lock of synchronized method and use it. Other threads have to wait till the lock releases and any one of them acquire that lock. It is important to use if a program is running in multi-threaded environment where two or more threads execute simultaneously, but sometimes it also causes a problem which is called a deadlock. So deadlock describes a condition in which two or more threads are blocked forever because they're waiting for each other. There are many causes of deadlock. The thread analyzer detect deadlock that are caused by inappropriate use of mutual exclusion locks. We can take an example if a transaction A might hold a lock on some rows in the accounts table and need to update some rows in the order table to finish it. To finish. So here we can see a diagram or example of a deadlock condition where where a thread is locked and another thread is also locked and they both are waiting for each other to release. So with this we are coming to the ending of this PPT. Any questions?